Hello, my name is Mitch Urban, and this is my data science project. It relates to endangered or threatened species collected by the IUCN RedList organization. My goal for this project was to create a regression model which scores species according to the importance of human intervention so that we have a plan of which species to focus on first and then next. I'm usually not thrilled with the data available from Kaggle or even government websites. So I decided to challenge myself a little bit and collect the data through the API for this. And it was actually pretty pleasant to work with. They have this documentation which you can create test calls, and it gives you a pretty easy interface to work with. Um, so the first three cells of this notebook are communicating with the API with these methods. The authenticate method fetch the categories, which are critically endangered, threatened, so on. And with these category codes, it then fetches the species in those categories. It also fetches what are known as assessments, which are thorough documentations of these species. So what we're doing is authenticating first, fetching the categories. If the categories are populated, print those, and then with that printed list, I picked out the ones that we wanted to include in the data, which were these. And for species that are in those categories, we save that to the species data list, dictionary. And these are all populated now with the assessments. So what we do now is get the taxonomy data for each species, which is sorted by category and species data in the dictionary. And then it is saving the assessment ID for later and the taxon ID for later. So these are it's now two dictionaries, one with the assessments, one with the taxonomy data, and then this one, species assessment data, is what we're going to be using for most of the project. And I also put this sleeper in here so that we didn't hit rate limits communicating with the API. But now that we have all of our data, we can go ahead and put that into a data frame. So we import pandas, create a blank list, and then we will append the data with all of the information that we gather from the taxon. This is a JSON file, so the way that this is working is it goes into this category, and then within that category, it goes into these categories. And then it's populating the list with all this information. And we are saving the data frame and then outputting it to CSV. And then here is what is in this CSV. This is Rainbow CSV for VS Code, which is what I use for Jupyter Notebook. And then we're cleaning the data here. We're dropping categories, setting the index as the name. We are getting everything set up to be numerical, pretty much just not object type. And then we see here that there are no null values anymore. These are all sorted into categories and bools and ints. Now that we have our data cleaned, we can create the model, which is from sklearn, scikit. And something I learned in another data science course is this k-fold model. What this does is when you're doing the train test split, you're only able to run it on 20% or so of your data. So you're ending up with just 1/5 of all of those values in your end results. What k-fold does is it folds the data 5 times or k number of times, and then it runs on each of those folds so that you're actually running over the whole data set in the end. I'm taking my list, running the model on it, and then compiling that back into a complete list at the end. And it's running with the random forest regressor for this regression, linear regression model. We're picking the feature columns. We are replacing the categories with dummy categories, and encoding. This is my intervention score. I'm creating my own weighted output prediction. So we're weighting these things together. You can actually increase the weight for each factor to tune your model to give you more accurate results. But I found that just leaving them all as weighted to 1 is giving me okay results. We are then setting X and Y, and here is the 4-fold method for training. It's finding the index location of X and Y, and then just keeping those in its memory so it doesn't iterate over the same training doc again. And then for each of those folds, it's running the mean squared error and the R squared. At the end, we have pretty decent mean squared error and R squared. I've been getting about 91% with this, depending on how the weights are configured. And then what we have is a list of species ranked by the importance of human intervention. This is by no means a complete model. There's still a lot of work to be done. Some of these species are not very threatened. A lot of them are dragonflies, which are experiencing habitation loss. And these are the importances of the categories in measuring the prediction for the intervention score, which it's really just doing a calculate prediction of how I'm weighting the categories, which categories are actually being included in the scoring. The model's not actually doing much. It's just doing a linear regression, obviously, but the correlation for the features, threats, and stresses seem to be down the board the most important factor in calculating the score. This is the actual versus the predicted scores, which actual scores are much higher, but the distribution is pretty congruent. But yeah, according to this model, the first species that we should be focusing on is the Streptocarpus congruensis. And by saving that species has the most danger to it. But again, this model needs a lot of work before it would actually be telling us anything important. But hopefully this is a good proof of concept for the idea of a machine learning model that gives us next steps. So thank you for watching and have a great winter break.